Hello and welcome to this lecture on our mesh node and testing. So let's have a little look at the beautiful mesh node we just created, which is inheriting from DAG, which is inheriting from DEP, which DEP itself is then also giving us the ability to access our attribute nodes, our object dimension class, giving us all of this ability very quickly to do a lot of amazing things. But I digress. Let's jump over and copy DAG dimensions. Here we go. Let's copy this. Oh, sorry, what am I looking at? We need to do testing. That's what we're looking for. And what we will do is we'll grab this and we will now go to tests and add, new Python file and test mesh node. Okay, and that's all fine. Brilliant. Okay, now there we go. Let's actually comment this all out at the moment. And we will say test mesh. Perfect. Okay, now let's jump and open up Maya. Okay, awesome. Let's run our awesome little module up there. Ran 120 tests in 1.08 seconds. Awesome. All of that work running so quickly. Isn't that great? Okay, and we've got no issues currently within our testing logic. There might be issues, but we just haven't found them. And again, that's where, like I said, our tests are definitely not exhaustive. There is a lot of space for you to write extra tests, and I would definitely say write all of those extra cases, like I've said, within attributes, within object dimensions. But these are just a bunch of basic and simple tests for us to kind of use as examples at the moment. So let's close Maya, or well, minimize Maya, and let's uncomment all of this. And what we are going to do is essentially set up, we don't really need any attrs for this. And what we are going to do is create these polycubes and polyspheres as mesh items. And we're also going to create two joints, which I'm sure we created a joint, didn't we, within dep node, was it? We did, here we go. Let's close that now. Mesh node, DAG dimension. Here we go. Actually, we'll just keep this joint name 1 equals call this body underscore joint 1. We'll actually keep that consistent here. We'll highlight that. We'll do body joint 2. Import mesh and DAG node. We'll create this as a DAG node. So what we're doing here is we are getting ourselves a sphere and our cube. And then what we're going to do is create a couple of joints. Because what we want to do is actually make sure that we have at least one item which has a skin cluster, just so that we can check that. So let's say sphere, and what we can do is go to our mesh node, get the Maya commands which we know work and have functionality. We're going to copy this whole chunk of code and take that into our class, and we are going to go mSkinCluster. We are going to say self.sphere, full path. We're going to use these two joints. So joint 1, joint 2. Actually, let's change these names a little bit. And these two can just be underscore name. I didn't mean to do that. So we can just go Control Shift and up and U to make sure these are both lower. But what we are doing is snake casing, which we're not doing too much really, but we will just use it for this scenario. And then we're going to use these arguments essentially instead of the keywords. Perfect. Okay, so now we essentially will have one item. We can actually, let's minimize this. Let's copy and take this into Maya and we'll test this. Let's get so let's press Alt and J. Cycle through and get every self, remove that self, and then we will test that we can build all of this within Maya. Okay, let's import our code. And then let's also make sure that we have imported our mesh item and our DAG node. Name error M is not defined, of course it's not. So import Maya commands as M. Try again. There we go. Cool. So it's all working. And yeah, so when we created Polycube, we still had that selected. So what we need to do is go m.select and clear equals true. All right, let's delete these and start again. This is why it's good to put things into functions because, yeah, you always get a little annoying things like this. Okay, perfect. So, and again. Perfect. Everything's flat. Okay. And we will check our sphere node has skin cluster on it. Perfect. Okay, everything's ready to go. Minimize. Let's remove. Sorry, what we're doing. We did all of that, and then we're not going to copy it over. That would be unwise. Okay, so what are we doing here? Let's have a little look. Major change is essentially just that we have select just before these items. So let's add this in. Perfect. Okay. Awesome. Okay, now let's start with our teardown. Okay, and now let's Control Shift Alt select those three items. And now I'm just copying them in there. So we're deleting our sphere, our cube, and our joint every time that we run a test or after we run a test. Okay, perfect. Now let's grab all of our DAG node, our mesh node functionality. Quite simply by selecting def, pressing Alt and J, holding that down. So I'm going to select the top ones as well. Yep, there we go. So now click right arrow till you get to the beginning of your function names. And then Control Shift and right arrow again. Copy those names in. Go over to mesh node. Copy those names. Delete verts. Let's double click arrow, double click Control, and then press down. And we are going to say tab in, def, and then test underscore mesh underscore But there we go. Okay, perfect. And then go to the end of the line by pressing Control and right arrow, and then do Shift and open parentheses, or just open parentheses, and all the code will populate. So let's just keep that all together. Go past for a second. Okay, amazing. So let's see if we can copy over all of our sections as well, just where we are separating everything. Those are quite useful. Might as well use those within our tests. So as your tests get bigger and bigger, you can, excuse me, still find all the required sections easily. Let's copy those in. Okay, and we will put duplicate down right at the bottom. It's putting it on top of things. Weird. Okay, topology. It has actually reordered a few things. That is very interesting. Okay, it might just be best to, oh, it's taking the pass out as well. Oh, interesting. Let's undo that. Okay. And let's just copy them across. So perfect. And there we go. Everything's nicely separated out again, consistently with the code that we already have written. All right, great. Let's cycle through, and now let's just check our mesh and verts. Sorry, our mesh, verts, and edges, and essentially our formation information. Okay, so what we're going to test for here is our functionality is just getting all of our verts as expected. So the name we're going to expect back is the dot, essentially within my dot notation, vertex 0 and 1, because we are gathering the verts in a flattened list, the same as the edges and the faces. And this will allow us to check that these names and the output is correct. So if we had a count function, we could also assert that, but at the moment, you could just do length just to get the length of this, so there's not really too much of an overhead. But let's copy this code, jump over to Maya, and ran 3 tests in 0.05 of a second. Amazing. Okay, great. Now let's just check what type we are, which again, nice straightforward test. Oh, come on, what are you doing? Faces, there we go. All right, there we go. Now let's copy the assert equal code. We're going to set equal to type. Going to be mesh. So let's run that again. Copy your code, jump to Maya. Remove the semicolon. That's not good. There we go. Add the semicolon back in, copy, jump back. Ran 4 tests. Great, in the same time. Brilliant. Okay. And let's come back to the more difficult skin cluster setup. Let's quickly check for tweaks. And we can also just check the duplicate output. So we've got our functionality here. For tweaks, we have to create essentially a tweak by adding a hierarchy and then moving the mesh once it is skinned and and even blend shaped here. So we're going to essentially add that into the hierarchy. And what we're doing is we are creating a duplicate mesh, so we can plug it in as a blend shape. We are then going to move the joint 2 up a bit so it's deforming with its skin cluster. And then we're going to move sphere vertices essentially just to a random place in space. And then we're going to plug in a blend shape from sphere 2, which is essentially just a duplicate, into sphere. And this will allow us to create a tweak with the move node, because we've moved verts after it's been skinned, and then we've added. So we'll get essentially a tweak node with those transforms stored within it. And what we're going to do then is assert that the depth node exists. And then we are going to delete the tweaks and then assert that we have deleted them. So let's copy the code. So let's go in and go ahead and copy in our code. Let's select all the code and enter. We've got one error. Okay. Unhashable type. Of course. Okay. We cannot essentially compare. What I'm doing here is I'm trying to delete duplicates, but it doesn't really matter here, because what we're then having the problem of is that we are getting a list of self-history, which are class-based DAG nodes, which set doesn't know what to do with. This is an unhashable type, a DAG node. So what we're going to do is just put a dot name there, and that should fix this. So let's close Maya, because we're going to fix this and then have to reopen. Jump into our mesh node, put dot name, and then if tweaks m delete tweaks. Okay, that should be fine. Oh, I put that in the wrong place. Let's put that at the beginning. So i.name. Yeah. Oh, there we go. Perfect. Okay, now let's try this all again. Let's open up Maya. So once Maya is open, let's copy in our test code again. Let's copy that. Jump back to Maya, copy in our code, and run. 6 tests ran. Okay, perfect. Okay, so we've deleted our tweaks as well. Oh, but we didn't delete our test sphere. Interesting. Okay, let's go ahead and fix that. So nice and simple fix, just delete them there. So let's go ahead and delete both of our duplicates. Oh, we've got 2 duplicates. What are we doing? That was crazy. So .delete. Copy that line and add the delete in above as well, because we've got sphere 2 there, sphere 2 there. So we'll delete both of those items. Okay, perfect. All right, now let's test our skin cluster and joints. So what we're going to do is first we're going to assert that self.sphere dot joints. It is sphere, isn't it? What are we adding the joints to up here? Let's just check that. Oh yeah, we're creating a skin cluster on sphere, and that will then have these 2 joints on it. So let's get those joints and just check that we are getting those. And let's pass in joint 1, joint 2. And then essentially all we need to do is here assert true. That our sphere dot skin cluster dot exists. Okay, perfect. Okay, let's run our code. So let's save that and copy all that code. Jump back to Maya. Copy our code in. A test ran perfectly. Beautiful. Okay, and now let's populate the rest. So a nice easy one. Firstly, what we're going to do is we are going to check that we copy over our skin cluster to the cube. So we're going to go self.sphere. Actually, we're just going to use weight 2, aren't we, here? So let's jump down here. So let's essentially go up to the top, grab our arguments back from skin cluster, come down to weight 2, and then we are going to go self.sphere dot weight to, we're going to say self dot joints, isn't it? So actually, oh, I'm doing this the way around, aren't I? Let's have a look. Let's jump to the beginning. Let's put in joints as this list of joints that we have. And then we're going to say cube weight to joints. And even then, we could put a few arguments in just to check that none of them error. Okay, and then what we're going to do is assert true that skin cluster and cube both have skin clusters that exist. Okay, great. Now, let's go through and copy weights to and from. So let's go mesh, copy weights from. We're going to give the item as a self.sphere. And what we need to do again is just now confirm that cube has a skin cluster and that exists. Okay, and our next point. So we're going to again, oh, actually, sorry, this was copy weights to. So that was the methodology for copy weights. Yeah, copy weights from. So copy weights from the sphere, and now we're going to switch that around and do sphere to self.cube. Okay. We'll change it to copy weights 2. Perfect. Okay, and then check again that the skin cluster exists on cube. So now hard weight 2. Let's use our joints again within both these classes. And what we're going to do again is assert that our test has run correctly. So we are going to soft weight 2. Let's copy out this cool soft weight 2 joints. Let's remove out the other information. Here we're going to hard weight 2. Just type it in. Hard weight 2. Okay, perfect. Now we have got a series of tests. We're not testing too many fail cases here and edge cases, but this is a good starting point essentially for us. So let's press Control, save, and now let us jump over to Maya. Sorry, I'm just lagging a little bit. It is now 2 a.m. and I am tired. So sorry, but here we go. I think all the code is still just as useful when it's running anyway. 13 tests run and 2 errors. That's not bad. Okay, copy weight 2. Mesh object is not iterable. Ooh, we're expecting a list, aren't we? Okay, perfect. So that is our first problem. So what we need to do is put that into a list. That will fix our first error. So copy weights 2, essentially we passed it a single mesh item, but it required a list. 1 error, great, what do we get here? Mesh for mesh in items. And now this one we should actually handle within the test case itself. So let's close down Maya. I'll show you what I mean. So we actually got the same problem here. We need to pass an item in a list because we're copying these weights across to multiple items. But what we're going to do is we're going to actually leave that. We're going to say that we'd run these checks within our class. So let's go back to our mesh node. Copy weights 2 and items. Now, if items, so items is going to equal, I'm going to override this. Items if items, sorry, I should say is instance items of a list or a tuple. And so if it is, it'll just keep it as is. But if it's not, what we can do is just encapsulate it. Items, perfect. Okay, and now this will essentially take care of that case scenario, or of this edge case where somebody might not be passing a list of items, but they're just passing a singular item. We're going to take care of that within the copy weights too. Okay, let's reopen up Maya. Press save in this file, and then go back to our nodes. Make sure we don't have anything encapsulated, and now go save, copy, and we're going to run our code. So let's clear out the panels. So press remove. Okay, press copy, press all, and enter. 13 tests ran, and yes, we got no errors. Okay, I love you guys. That's brilliant. Okay, I'm emotional. I'm tired, and I'm ready for bed. But we've got test cases running in a complex, directed, acyclic graph system, and these are awesome. We have got a tested now Maya system. Actually, what am I doing? Let's reopen Maya and actually run our tests. We'll do an example of how this is useful tomorrow. We'll do maybe a little update script, which is just a few lines, but when somebody passes you new mesh to update in a rig, it can be a nightmare. So that's why I've written that into a little script that essentially runs through its mesh. It checks if there are lattices, checks if there are blend shapes, skin clusters. It checks for the materials that are on them. It checks for a few parameters. And again, because I'm using a nodal system, all of those checks are one line and then another line for assignment. So it makes life very easy for me. We'll cover this in the example, which I'm going to do after a sleep. But here we go. Let's open up and run our test. How gorgeous is that? Okay, great. We know our system's working, or at least with the logic that we're testing with. But thank you. Anyway, good night from me, and I'm going to see you in our next lecture on the example code for this class. But well done, guys. I'm seriously impressed because you've come a long way, and it took me years to learn all this stuff. I've worked with a lot of great people out there. You know who you are if you're listening to this, and I'm honored if you are because you are far smarter than this. But they've taught me some amazing things. And again, this is only because I've worked with amazing people that I've been able to learn amazing stuff. And that you obviously take the time to do it yourself. But okay, I'm very happy to be able to share that knowledge with you. If I can leave any legacy with anything, it'll be that I leave some knowledge on this planet to help make it a better place. But great, I will see you in our next lecture on the mesh node example. Thank you so much, guys.